Okay, so assuming that you did not do the homework, it's as simple as this. So for those of you who might have been confused or didn't know what to do, my question back to you is, what part of it was confusing? There are two things that you have to do, and you need to understand what it is that is confusing to you. You need to pinpoint your question. If your question is, I don't know how to do it, that's not good enough. That means you haven't really thought it through. Come to me with a specific question of, how do I even start? Or what does that number mean? Or how do I calculate this? If you're coming to me and saying, I tried it, but I just didn't understand, that's so vague. To me, that sounds like I didn't try, but I don't want to make you feel bad, Mr. Kim. That's what it sounds like. I don't need that. What I would rather you say is either I didn't try it or I didn't know what these numbers meant, or just ask a very specific question. Okay? Starting off, anytime you're given an equation and you're asked to graph it, the only clues you have are these two numbers, this number and that, this number and that number, this number and that number. In fact, if you have those numbers, or if you can find those numbers, you have everything you need when you're graphing. Pay special attention, please. The first number that is multiplying with the x term is what we call the slope. It is my rise over run. It is my rate of change. It is how I am moving on the line. So you might want to take this out if you have it. Evan, you too. Take out your sheet, please. The second number in the equation, the standalone, whether it's a plus or a minus, does not matter. This is what I call the Y-intercept. It is also, in casual terms, the initial value. So, in loosely describing this, you can say that the 4 is how I move, and my B is where I start. Logically, what number do you want to work with first? How I move or where I start? Yeah, logically. So you will use the y-intercept of 1, which of course you need to know is the point 0, 1. I start right there. From there, I am moving with a rise of 4, positive 4, and a run of positive 1. It's literally 1, 2, 3, 4, and then 1. 1, 2, 3, 4, and then 1. Nope. It is a 5, but I started at 1, right? So that's why the initial value is important. On the flip side, if my slope is 4 over 1, in other words, if my slope is a 4, I could also argue a 4 can be gotten from a negative 4 divided by a negative 1. What I mean is, I can go the opposite direction. If going up is positive 4 and positive 1, I can also say that I can go down by 4 and left by 1. Down by 4 and left by 1. And if I connect the dots, ta-da, straight line. If you have your slope, if you have your y-intercept, you can graph it. I hope this is useful for you. Please practice it. Okay. The point, there's no, I would rather you actually do these 4 graphs very quickly before we talk about the next section, which is this thing called vertical versus horizontal lines. All right? Don't worry about that. We'll have to do some quizzes first. So the other 3, please try it. I'm going to give you like 30 seconds for both. Try to finish this in 2 minutes. I'm going to come around to make sure that you're good. Okay, so for the second one, I'll be really quick. Slope is a negative 2 over 3. For the sake of drawing this graph, I will write a negative 2 over a positive 3. And then I'll switch up later saying it's a 2 over a -3. They are both the same slope. My b value is a -2, which means I am starting right there, right? The coordinate point 0, -2 is one of my points on the line. Let's do it. Rise is -2, run is +3. So I go down, rise of -2, and run of +3. Rise of -2, run of +3, and so on and so forth. Great. I'm going to use the other form of this fraction. I have a +2 as my rise, so I go up by 2. But I have a -3 as my run, so I'm going left in the negative direction. And I know I'm doing it right because it follows the same trend as the other x's that I drew. There it is. Okay. Slope is -2 over 3, and my b value is a -2. Yes? In this direction? Yeah. It would, you are overlooking the negative in one of them. It has to be in this manner because if you think about it logically, my rate of change is, it's lowering, it's going down. So it makes sense I'm going down. Yes. One sec.
So there's the 2 over 3 on one side. And then how do you get the fraction on the other side? Oh, I don't know.
You got it? Okay. Yes, madam. Right. So when we were first learning about the Cartesian coordinate, we are always going from left to right. So it's always either going downhill or going uphill. So it's always left to right. It's the only way to make sense of this negative idea. Okay. It's already on video, so if you want more pointers, if you want to make sure you're doing the next two right, you can always check the answer key, or you can visit the video later on. The reason why I needed everyone to be comfortable with this is because the next portion is just to finalize this lesson. And this is interesting. It requires a little bit of thinking and not as much calculation. How do you describe an equation if the line is vertical or if the line is horizontal? So to address this first, I'll ask you a question. Let's do horizontal first because it's a little easier, I think. Ready? This is my line. Based on what you know about slope, is it going uphill or is it going downhill? You can argue then my slope is a 0. Right? What's my initial value, aka what's my y-intercept? It's a 2. So my m is a 0, my b is a 2. If you plug this into the equation, what do you get? 0x plus 2. Would you agree? Slope is a 0, my y-intercept is a 2. X is being multiplied by a 0. So, for example, 0 times a 1 is 0 times 10. 0 times -99. No matter what my x is, this is going to be a 0. This term is going to be a 0. Therefore, there's no need for a lazy mathematician to write that. The equation of a horizontal line is y equals whatever your b value is. Some of you are going to memorize this. Okay, horizontal line, y equals b. Other people will be like, oh, that makes sense because the slope is a 0. I'll just do what I already know. But that's going to end up being a 0. So there. Some people are not going to memorize 2. Some people are going to memorize 2.
4444. Miss Janice, please call 4444. Thank you.
I highly recommend Don't memorize this idea, but understand that your slope is a 0. So by default, I get y equals b. Memorizing just takes up brain space, that's all. Okay? So anytime you see y equals a number, it represents a horizontal line because the slope is a 0. So for example, let's do it here. Please look at letter A and letter C. What do you notice? Y equals -2. What does that mean? Stephanie, you with me? Are you tired? I'll wake you up. Do you see an X here? Then it somehow disappeared. Can you explain why an X might disappear? Why did that term turn into nothing based on the slope? No? That's it? Yeah. So the slope, when you see this, automatically it's a horizontal line. Slope is 0, that's a -2. So starting here, b equals -2, you can draw yourself a horizontal line. Y equals -2 is right here. So I will label that y equals -2. I'll do it in blue. What about C? Okay, but no, continue though.
I was just saying that if y is -2, but if the line is like vertical, then I realized it's not going to be that.
Well, you'll actually get there, and you'll see why that this makes sense. B in this case is a 5, right? Because the x term is gone, all that's left is the b value. We have bam at 5. This is y equals 5. Any questions? The reason why I'm talking about horizontal and vertical lines is because that's the final, I guess, final chapter of straight lines. If you understand this portion, everything you need for y equals mx plus b, the introduction, we're done. So we're just wrapping this up. Well, since we talked about horizontal lines, of course, it's now time to talk about vertical lines. Vertical lines is not much, it's a little bit tough of an explanation just from slope. So I'll ask it anyways and stump you. Take a look at that vertical line. What's the slope of this vertical line? And I'll give you a hint, it's not a 0. Why is it undefined? So it doesn't go through the y-axis. This is true, but let's talk about the explanation based on like real life scenarios. Does that look more like a staircase to you? No. If you had to make a metaphor or an analogy of this line as a movement, what does that look more like than a staircase? A vertical up-down looks more like this than a staircase. An elevator. Okay, so let's talk about an elevator. That's a good suggestion. How high can an elevator go to raise you somewhere? Yeah? Essentially, it can go up 1 level or 1 floor. It can go up 5 floors. It can go up 10 floors. There's no limit. So the question is, can you put a number to how high I go every step? No. That's why it's undefined. You can't put a number on it. You can't define the number. There is no number that fits the question. It's undefined. Another way some teachers might explain this is that, well, I can go up an infinite number of floors without changing my x value. And so this is not a possible number in the math language. You can't divide by a 0. You can't do infinity divided by a 0. And so there is no number. Which brings us to my point. How do I put an equation on this? My second question. What's my y-intercept? Is there a y-intercept? So now I'm stuck. Nothing we've learned so far fits. So how can we still give an equation for this? It says on the paper.
The x and put something so you can use the x.
Sure. Do you see that right there? Here's my explanation. What point is that right there? Give me the coordinate of that point. Are you with me? Can you give me the XY point of that location? Stay awake. This is important. Come on. Look at the paper. What is the XY of that point? Other way. 5, 0. Okay, I'm going to write that down. 5, 0. I'm going to go up right here. Maddie, I'm still with you. What is the XY point of that location? Good. I'm going to write that down. Okay, I'm still with you, Maddie. What about that one? 5, 2. And you don't have to think much, do you? What about the next one? What about the next one? What do you see in common with every point on that line? X is always a 5. And so we give it the equation x equals 5. Why does that make sense? Well, if x equals 5, well, you might ask, what's y? Y can be anything. So from a mathematical perspective, it's not important what the y is. The only thing that's important is the x. So we say x equals 5, done. Vertical versus horizontal lines. There's a logic behind it. And for example, if you're tired or you're looking at your phone, or I understand, but there's a logic behind why we define it as y equals something and why we define it as x equals something. Even if you're not paying attention right now, I hope that you'll be able to understand the logic. It's not magic. It's not a rule. There's a logic behind it. Okay? So x equals 4. What does that mean? It means every single point has an x value of a 4. So I'm going to put that together. Every single point on this line has x equals 4. This line is x equals 4. Same with the bottom one. How about I do it in red? X equals -3. When x equals -3, I don't care about the y value. Every point on this line has x equals -3. So that is called x equals -3. As a recap, we have looked at lines that are like this. We have looked at lines that are like that, right? Going up or going down. We've looked at lines that are really steep or lines that are super shallow. And then we've also looked at horizontal and vertical lines. We've covered every type of line out there. We've also looked at how we can go from a graph to an equation, or an equation back to a graph. We looked at table of values. You've basically looked at every single thing. The second half of today is going to start using these equations to help us out. So here's what I'm going to do. We're essentially done this portion of the lesson. Lesson 3 is not long, but I wouldn't mind having a little bit more time to go through it with you. So I am going to ask you to, if you haven't done so already, practice some of these homework questions you were supposed to try. Well, I actually didn't assign it. practice some of these homework questions, like numbers 1 to 11. Maybe you want to try every other just to get your feet wet. And then in about 30 minutes, I'm going to send you off on a bit of a break. Don't walk around the hallways too much because it's going to interrupt the other classes. And then at exactly 1:40, I'm going to begin the next lesson. Okay, 30 minutes, try the practice questions, take a 20-minute break, and we'll start the next section. Question? No, share it with me.